Hi, in this video, this is actually a follow-up to my last video where I took apart this Global Systems Navigation Databank, which is an optional unit for the GNS-500 navigational system. It's typically sold to the business jet market, and this unit contains coordinates for roughly 20,000 airports worldwide. It just saves the effort of having to manually enter the coordinates into your navigation computer. This thing does it for you automatically. In the first video I took it apart, did a teardown video, and I tried to power it up and came to the conclusion that the power supply board here is either faulty or it needs a remote power on signal. That's as far as I got with it. So I decided to play around with it a bit more, and I started by tracing out connections to the rear connector here, which go to the power supply board, and indeed several do. There's a couple of LM317 regulators here. They provide power to two of the pins on the rear panel, probably for powering external devices. And there's a Uline 2003A down here, which goes to the various MOSFETs and the two control chips here. And it looks like it's actually, that is the remote power on, so in order to reverse engineer that, I found this crude circuit diagram. There's 5 pins here which switch on various parts of the power supply. These 4 here go to the rear panel. Now the Uline 2003A has a built-in 2.7k base resistor, and it's designed for logic level inputs. However, for these 4 inputs I've got a 3.3k resistor in series with the input, and that makes 5k, and if you divide 28 volts by 5k you get 5 milliamps, which is the required level to turn on the transistor in these chips. So in theory, applying 28 volts to one of these should turn some on. This 5th output here doesn't have a series resistor, and that goes to the CPU board, so that probably switches on the power to this front data module. Now let's pull the power supply board out, and as you can see, if you look at the back of this Uline 2003 here, first 4 outputs are all joined together. So my theory is, if I apply 28 volts to any of those 4 pins, the inputs obviously, something should turn on. So basically, yeah, the scope of this video is to try and power this thing on. And as it has 3 RS422 ports on board, I thought I'd see if I can see if any serial signal could come out of it. If you look at this crude circuit diagram, that's probably turning off. Yeah, that's a crude circuit diagram, so that pin's not going to be connected to anything, and this final input here goes to this 74HC04 inverter, which in turn goes to some of these other components down here. I haven't quite mapped that out yet, but yeah, so I think what we'll do now is see which one of these pins go to the rear plug. And I think it was, so I'll just pause this while I trace this out. Right, one of those inputs that's joined in parallel goes to the 4th pin in on the bottom row of this back connector, so I'm just joining a little jumper wire here. Let's put that on. Right, okay, so let's apply your 28 volt supply to the unit first of all. Right, it's now powered on, it's joined 62 milliamps, which meter volts, and at the moment there's nothing across these capacitors. The power output you've got here at this moment in time is this pin 8, which is outputting roughly 8.4 volts, and that goes to the ARINC interface board. So that's some sort of standby power. So at the moment, yeah, there's no voltages across these capacitors. so the power supply is effectively shut down. So in theory, if I now set a current limit of 528 volts to the input of that, something should come on. Oh, there we go. It's showing 377 milliamps now. I think I might have got lucky. Have we got anything now? Oh. 129 millivolts. Let's switch that for a moment, see if anything's getting hot. Are you sure? That should work. What have we got across here? Oh, we've got a voltage here now. There we go, 12 volts. So something has turned on here. So they've got a 12 volt supply. What about this one? Still nothing there. How about this one? 5.1 volts. Right, so we've got 5 volts and 12 volts now, so I think that was quite lucky. I think I've got it. Now let's see. Just for a moment. I don't want to short anything out on here. Come on, yeah, there we go. Right. See what voltages we get now. There's 3 power outputs on this. So we're getting your 5 volts, and your 12 volts. These are your power pins here. Put that meter there so you can see it. So I need to better see it as well. So, right, cool. So what do we get on the white one? The only one, nothing. 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 Right. All these white wires here go to the back panel. These are your ARINC data there. White wires. Do we get anything on there? Stranger, there's no power going to it now. Right, let's see if we get any power on here. So you can see there's 3 power rails on this thing, like I said earlier. Obviously one of them's not powered up, so these white wires here all go to the back panel. These are your ARINC data pairs. See what's on the orange wire. 160 millivolts, right. Red. Right, so the red wire is 5.1 volts. What about this white wire? That is actually a power pin. 28 volts, right, there we are. So this front power module here needs 28 volts. But that is actually switched through a MOSFET, so 28 volts there. Yeah, so there's only partial power here. So there's 5 volt power. But whatever this orange wire is here, there's no power on that. That probably gets turned on by this fourth pin here. Well, sorry, 5th pin there. And that comes from the main board. So I would imagine that at this point the CPU board's powered up, and it will turn the other power rail on when it gets a signal from the ARINC bus or down the serial port. So at this point, should be seeing data signals on these pins, and the thing appears to be powered on. Just that one of the voltage rails is missing, the yellow one. So the orange one, 179 millivolts, so that is powered off. So my guess at this moment is it's waiting for a signal to fill the power on. I think we might have cracked it. So I think the next job is to get the oscilloscope out and see if there's any pins, any data on these ARINC pins here, and the RS232 sorry, RS422 pins down here. So, right, that's the next step. Right, like I said in my previous video, I don't expect to see this do much, because all it is just providing data to another device. I did disassemble the EEPROMs on the boards, and I couldn't find any text strings, so it doesn't appear to have a serial interface. But let's get that meter out of the way. If that's in shot or not, but let's see from. I can move this around a little bit. So if I now put this on the case, which is ground, power it on again. It's got tangled around my meter probes. Bloody hell. Put two wires together like that and they immediately get tangled into the most complicated knot known to man. Right, this thing's powered on. Right. These pins, these two boards here are Arink interface boards, so any data on here. Oh, volts division, we're set on 5 volts per division, so let's change that to 1 volt per division. So these are differential pairs, there's nothing there. I think it's probably waiting for another power on signal. But the remaining power on signals come from the CPU board, so there's 3 RS422 ports in this thing as well as Arink, so the Arink boards are getting power. Nothing on the Arink data lines though. No, nothing. Probably set to ×1, yeah. What about the signals on the, goes to the memory unit. That's your 5 volt power. Nothing. Well, obviously at this point the CPU board, like I say, has got power. Arink boards have got power. And there's 5 volt power and 28 volt power to the front memory module, but also that's like a third power rail which isn't on. Yellow, I mean it's not orange wire, so that might be 3.3 volt. But there's nothing here. I keep poking around and I'll come back when I find a signal. I did try taking the CPU board out and powering it from 5 volts directly from the bench power supply, and it did come on because there was data on the CPU's address and data lines, so there was nothing on the serial ports, but there was definitely data on the RAM chips, the ROM and the CPU. There didn't appear to be anything going to any of these boards. So maybe this unit is actually knackered, and that's why it was scrapped. It didn't come with any paperwork to see whether it's serviceable or not. But yeah, absolutely nothing. Ah, there we go, finally found a signal. So the CPU board's definitely running. There we go. That's just data. And they go to the ARINC board. So nothing on the ARINC outputs there. And this is getting warm, I can smell it. What about the ROM module? That doesn't appear to be powered up, there's no data on any of these pins. So that probably does need that other power rail to turn this on. I'd imagine that CPU board wakes up in this thing. There's a power on signal from the main GNS-500 unit which turns the CPU board on in this thing. And it won't turn the rest of it on until it gets a signal from something else, or when it's actually needed. You have to save power. I mean, in aircraft, power usage is quite important. So turn things off that aren't needed. Saves fuel and minuscule amount of fuel, but nevertheless. It's got data on these pins here, but where do these go? They definitely go over here. Oh, yeah. But there's no serial data on it. So it's not sending any data out either. It's not sending the data out on the ARINC ports or the RS-232 ports, so it's probably waiting for a signal from something else. But I don't think it's going to do much else really now, unless I send the correct signals to the serial port or the ARINC port. This ain't doing nothing. There's no serial data there at all. These are your RS-422 ports here. The previous attempt, I'm just going to do a bit of paper here. I did actually map out pins. You can see the two RS-422 chips. Basically it's all these white wires here, so I think what I'll do is play around with it a bit more and I'll come back. Right, well I've confirmed there's nothing on any of the ARINC boards, so there's no communication to the ARINC boards from the CPU board. So my guess is it's waiting for another signal, either on RS-422 or the rear plug to turn on, but there's no more connections from the power supply board to the rear plug. I mean, there is obviously from the CPU board, but I don't know what they're for or what voltage it needs to turn on, so I presume 5 volts, but there is that last pin, which is pin 13 on the CPU, which is that one there. That's the other one. If I put 5 volts on there, it might turn the other power rail on. I could try that. Jumpering it through a 1 kilo ohm resistor. Right, okay. And see if it turns the other pin on by drawing, if it draws more current. Doesn't. That's now tied to 5 volts. I mean, what is the voltage on that pin? It might be 5 volts to disable it, so 108 millivolts. Right, okay. So that's got 5 volts on the other end. Shots or anything else. Well, I didn't draw any more current. Right, let's try, see if we get anything on these other pins now. I get nothing on before. If I touch that, it's 5 volts. No, so that obviously doesn't turn on the other power rail. I touch it by switching on the other Ullin 2003A pin. Right. So my guess is it's probably some sort of the other two remaining inputs. And one goes to that 74HC04, which in turn goes to a comparator, which goes to these two voltage rails here, which connect to the rear panel. And the other side of the comparator goes to the logic board, so I would guess it's comparing two different voltages, and if the voltages are correct, it will then turn on the logic gate, which in turn turns on this, and that turns on the other power rail. So, right, okay. Well, basically this thing is going to need quite a bit of time spinning like to reverse engineer it, and to be perfectly honest, I don't expect to see much. You probably just see might see serial data coming out of it, but it'll just be garbage. Like as I opened, got the ROMs and took an image dump of them, there's no text strings found. I've disassembled the code back to machine code assembly. I'm trying to reverse engineer that, but there's no indication of what control codes are sent to these rear pins to make it turn on or communicate. Obviously it's probably over a link bus. This thing is powered on, but there's only a few signals I can see on the scope. They're definitely still in a partially powered down state. Very odd. The only signals I can find is these two here. Or these three. See where they go. That didn't go to the memory board as originally thought. There's signals on these two pins here, but nothing connected to them pins. It's these underneath here that have wires connected to them. Right. Well, in that case, I don't think I'm really getting anywhere with it. I think it may well be knackered. It's per my original thought. There's no data on any of these other pins here, and I'd expect, even if it was in some sort of standby mode, there'd be some sort of data on these pins here. And so it needs a signal from the link bus to turn on. You'd expect communication, but there's nothing. I've looked online and I can't find any technical information on this thing at all, so it's quite unsurprising. Yeah, there's nothing. Absolutely nothing. There are two signals I can find are these two, and they don't go anywhere. That one as well. There's nothing connected to that either. Well, I think I might have to end up calling this a day now. End of the day, I could bug around with it for hours, and I'm not going to be able to get anything useful out of it. All I know at this point is it does actually turn on. Yeah. I think we'll leave it there. I think this video has gone on for way too long at the moment. I'll edit it down a bit, but yeah, I think it's not going to make a very interesting video. This, if you did make it this far, well, thanks for watching. But I think this thing I'll call it a day for now. I mean, I might poke around with the back panel, see if I find any signals on there, but I very much doubt there'll be nothing. Yeah. Yeah, I think it's either knackered or it needs further power on. I mean, I've got the 5 volt, 12 volt rails come up, but nothing else. So there's obviously a third power rail there on that orange wire, but that won't come up. It could be the power supply that's faulty. That cover's meant to be supplying power and it isn't. Might have some sort of power good monitoring and it won't actually work unless if all the power rails aren't working. That's probably what that comparator's for. So it could still have a power supply fault here, but yeah, I'm not going to bugger around with it any longer. But if anyone does have any technical information on it or has worked on one of these things, I'd be grateful if you could let me know down in the comments. But for now, I think we'll call this a day. Thanks for watching.